Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to identify right formulas and find terms of an arithmetic sequence. The instructions for the examples that we're going to be working on, the first set of examples, are as follows. We're to determine if the given sequence is an arithmetic sequence. Okay? We're going to determine if it's an arithmetic sequence. If it is, if yes, then we have to do something further. If yes, we are to find the common difference. Find the common difference, which is represented by the letter D. Okay? Alright, so question number 1. Let's say we have the sequence given by 5, 9, 13, 17, ... Okay? So first of all, we need to know what a sequence is. A sequence is just a list of numbers, okay, like we have here. And these dots basically mean that this list of numbers continues forever. Alright? So the question is as follows. Is this sequence or list of numbers arithmetic? Is it an arithmetic sequence? So in order to determine whether it's an arithmetic sequence or not, what we're going to be looking for is something called the common difference between consecutive terms. Okay? Consecutive terms are terms next to each other. For example, if you have 1, 2, 3, 4, 5, 6, a sequence of numbers like that, consecutive terms are the term that's right after the other one. Okay? So 5 and 9 are consecutive terms because they're next to each other. 9 and 13 are consecutive. 13 and 17 are consecutive. Okay? 5 and 13 are not consecutive because they are not next to each other. Alright? So let's look at what the common difference is, or the difference between consecutive terms. So from 5 to 9, the question is, what is the common difference from 5 to 9? In order to find a common difference, you just subtract. Okay, so we just say 9 minus 5, and 9 minus 5 is 4. So since 9 minus 5 is 4, that basically tells us that what we're doing is we're adding 4 in order to go from the first term to the second term. Okay, now what if we want to go from the second term to the third term? What's the common difference there? All you do is just subtract 9 from 13, right? So how many units does it take you to go from 9 to 13? You add 4. Alright, so that's the common difference. And then if you want to go from 13 to 17, what's the common difference again? You add 4. Alright? If you want to do the calculations, we can do that on the side. So for the first common difference, you do 9 minus 5. That's 4, the first common difference. And then the other one, we had 13 minus 9. If we do 13 minus 9, let's do it on the side here. 13 minus 9, we get 4. And then when you do 17 minus 13, you get 4. Okay, so this is another way to do the common difference. You just subtract consecutive terms. The formula for that is A2. You can do A2 minus A1, or you can do A3 minus A2. You can just subtract consecutive terms. All right? Okay, so what we see here is that the common difference is the same constantly. Okay? So whenever you have a situation like this, this is exactly what an arithmetic sequence is. It's a sequence of terms where consecutive numbers have the same common difference, or the difference between consecutive numbers is exactly the same. Alright, so our answer to this question is yes, it is an arithmetic sequence, and the common difference given by the letter D is equal to what? Is equal to 4, because this is a constant difference between every consecutive term of the sequence. Okay? Alright. Now let's go ahead and take a look at another example, question number 2. Now what if we have a sequence or list of numbers given by 14, 12, 10, and 8. All right. So is this an arithmetic sequence? Or in other words, do we have the same difference between any two consecutive terms? All right, we have dot 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 because the pattern continues forever. All right, so let's go ahead and copy down the sequence of numbers. Then let's go ahead and determine what the common difference is. All right, so let's ask ourselves, if we go from 14 to 12, how many numbers, what do we add or subtract to 14 to get 12? You subtract 2, right? How about from 12 to 10? How do you go from 12 to 10? You subtract 2, right? And how about from 10 to 8? How do you go from 10 to 8? You subtract 2. So what you notice here is that you keep subtracting the same number every single time. That tells us that this is a common difference, an arithmetic sequence, and the common difference is -2. Okay, so just a side point, the way that terms are numbered in in an arithmetic sequence, they are enumerated using and an index that represents the position of the number. So for example, in this sequence we have here, A1 is the first term. A2 is the second term. A3 is the what? The third term, right? So if you just have A, we have A, the index represents the position of the term in the sequence. So A4 represents the fourth term. So when looking for the common difference here, you can either say A2, the second minus the first, or you can say A3, the third minus the second. These are consecutive terms. Or you can say A4 minus A3. So whichever computation you do, you will always end up with -2 based on what we have here. Okay? So since the difference between any two consecutive terms is exactly the same, ladies and gentlemen, we have an arithmetic sequence. So the answer is yes, it's an arithmetic sequence. And the common difference, which is D, is -2. Another thing to keep in mind is that the sign of the common difference will tell you if the sequence is going to be increasing or decreasing. Okay, so in the first sequence, you notice that it was increasing. That indicates that the common difference will be positive. But when it's decreasing, the common difference is going to be negative. Okay. All right, let's take a look at another example. Now let's say we have the following sequence of numbers. Let's say we have the sequence given by 5, 8, 12, 17. We're still answering the same question. Is it an arithmetic sequence or not? If it is, then indicate what the common difference is. Alrighty? So we have 5, 8, 12, 17. Now, first question, is this an arithmetic sequence? To determine that, we're going to ask ourselves, what is the common difference? Okay, when we subtract any two consecutive terms, what do we notice happening? From 5 to 8, that's an increase of 3 plus 3. From 8 to 12, that's an increase of 4. Uh-oh, we have a problem. The common difference are not the same. So this automatically shows us that this is not an arithmetic sequence because the common difference must be the same every single time. Okay? And then from 12 to 17 is a common difference of 5. So our answer for question number 3 is that this is not an arithmetic sequence. Why is it not an arithmetic sequence? It's not an arithmetic sequence because the common difference is not constant. It has to be the same. It cannot change in order for it to be an arithmetic sequence. All right. All right. Let's take a look at another example. Question number 4. Let's say we have the sequence or list of numbers given by -3, -6, -9, -12, and the pattern continues forever. So the first question is this sequence arithmetic or not? Well, let's see. Let's write down the sequence again, and then look at how the terms, look at what the common difference is. Alrighty? So from -3 to -6, it's more negative if you subtract the two numbers, -3 to -6. The common difference there is -3, because -3 minus 3 is -6. From -6 to -9, what's happening there? You subtract 3 again. Oh, it's looking like an arithmetic sequence. How about you go from -9 to -12? You subtract 3 again. So what is the conclusion here? This is definitely an arithmetic sequence because the common difference is constant. The difference between any two consecutive terms. Alright? So our answer is yes, it is an arithmetic sequence, and the common difference given by the letter D is equal to -3. Alrighty? Alright, so for the next example, we have a different set of instructions here. So the instructions for question number 5, we are to write the equation. You can also refer to it as a formula. The equation for the nth term. Write down the equation for the nth term of the given arithmetic sequence. Okay. And then secondly, we're going to then find the 30th term. Find the 30th term given by A30. Okay? Alright, so let's go ahead and do it. So for question number 5, let's say we have the arithmetic sequence given by 2, 4, 6, 8. So first things first, we want to find out what the equation for the nth term is. To get us started, we're going to write down the formula for the nth term of an arithmetic sequence. So the formula for the nth term of an arithmetic sequence is given by an. The nth term equals a1, the first term, plus n, the number of terms, minus 1 times the common difference, d. Okay? Alright, so let's specify what these components mean. Let's state them on the side. So an is the nth term, a1 is the first term, n is the number of terms, and d represents the common difference. Okay? Now, let us take a look at this situation that we have right here. Let's find out what the different components are. So, let's see. Let us start by taking a look at what A1 is. Okay, so A1 is the first term. So in this sequence that we have right here, the first term is 2. Okay, so remember this is A1, A2, A3, A4. And then the number of terms, when we are writing down the formula, is just given by n. And then the common difference D, what's the common difference here? The common difference is basically how the difference between consecutive terms. So from 2 to 4, or from 4 to 6, or from 6 to 8, what's the common difference? As you can clearly see, in every case you add 2. So it's plus 2, plus 2, plus 2. Alright, so the common difference can just be calculated. You can say you subtract the second term from the first term, and you get 2. So the common difference is 2. Okay, this is just the formulaic way of calculating it. You can also calculate it by looking at the sequence of numbers. An, since n, is going to be given by a sub n. Now the formula or the equation is given by, let's write the formula here. We have let's write the formula. An is equal to a1 plus quantity n minus 1 times the common difference. Okay, so what are we going to do? So what we're going to do is we're going to take the common difference, which is 2. The common difference, we're going to plug it in for d. Okay, and then we're going to take n. N stays the same, so just take n, stay as n. And then a1, the first term, a1 is going to be plugged in right here. Okay, so when we carry out the substitution, what do we get? When we carry out the substitution, we're going to end up with the formula. Okay, so the formula is going to be an equals a1, which is 2, the first term, plus quantity n minus 1 times the common difference of 2. Now we're going to have to simplify this completely, okay? So we're going to distribute this 2 to 1, negative 1, sorry, and n. When we carry out the substitution, the distribution, we're going to have an equals 2 plus 2n minus 2. Okay? Now, are there like terms that can be combined? Absolutely. Negative 2 and positive 2 are constant, so they can be combined, right? So when you combine positive 2 and negative 2, you end up with 0. And our final answer, the equation, is going to be given by an equals 2n. Alrighty, so that is the formula for the nth term. Formula or equation. Alright, now let's take a look at the second part of the question. The second part of the question asks us to do something. We're asked to find the 30th term. Okay, so let's go ahead and do that. So we want to find the 30th term. So to find the 30th term, let's write it down. Find the, or just find a 30th. So let's say find a 30th. So a 30th basically means the 30th term. All right. You just look at the index to determine what the term you're looking for is. So we already have a formula here, an equation that which we're going to be using. An is equal to 2n. And we also know that n is given by 30. So if n is 30 and an is 2n, the 30th term, so an is now going to become, plug in 30 for n, a sub 30, the 30th term, is going to be, instead of 2n, we're going to plug in 30 for n. So it's going to be 2 times 30. And our answer, a30, is going to be 60. Okay, so 60 represents the 30th term. Alright, now for the next example, we're going to take a look at a real-life scenario using arithmetic sequences. So for question 6, consider the following scenario. Jasmine places a $500 deposit for a new Galaxy cell phone. Okay, for a new Galaxy cell phone. And after that, she pays $50 a month, every month, for her service. Okay, for her data service. The question is as follows. We have to write an arithmetic sequence, right? an arithmetic sequence to represent how much Jasmine spends on her phone every month, to represent how much she spends on her phone every month. Alright, so after writing down an arithmetic sequence, you're then to, so this is the first part, write down the sequence, and then write down a formula, to calculate how much she spends, calculate how much she spends. And then lastly, find how much she spends after a year. Find how much she spends after a year. All right, let's take a look at the first question. Let's write down an arithmetic sequence, okay? So an arithmetic sequence for her scenario is as follows. She starts out with 500, right? And then what happens? She adds $50 every month. So starting out with 500, she adds $50 to get the next figure. So for the first month, A1, she adds 50. So plus 50. What do you get when you add 50 to 500? So starting with a 500 deposit, she has 550. And then the next month, what does she do? Add another 50 because it's a $50 flat rate, right? And that gives us 600. And then the next month she adds another what? She pays another $50. Every month she pays $50, right? And then that gives us 650. And then this pattern just continues forever. So how do we represent that? We just use dot 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 dot. All right? So her sequence is the arithmetic sequence that represents the money she spends on her phone is starting with 500, it goes to 550, 600, 650, and then it goes on and on and on. Okay? Alright, so there goes the first answer. Now the second question is for us to write down a formula to calculate how much she spends on her phone. Alright, so we have the sequence. Now let's write down a formula to help us with the calculations. So for the second one, we're going to start off by writing down the formula for the nth term of an arithmetic sequence, and that is given by, so we want to find the formula here. Find the formula. So the general formula an is given by a1 plus n minus 1 times the common difference d. Okay? So in her particular situation, her starting value a1, the first term in the sequence this is a1 right here, the first term, that's a1, is 500. Okay? And then n is just going to be n since we're looking for the general formula. The common difference is how much she pays every month, which is 50. As you can see here, she adds 50 every month. And then an is just going to be an. Alright, so we're going to plug all this into the formula, the arithmetic sequence formula, which is an equals a1 plus n minus 1 times the common difference. Alrighty? So the common difference, which is 50, we're going to plug it in right here. N, which is just n, we're going to plug that in right here. It's not really plugging in, it's just the same thing, right? And then we have a1, which is 500. We substitute that for a1, and an is just an. So we're going to have the equation an equals a1, which is 500, plus n, which is still n, minus 1 times the common difference of 50. Okay, so now let's go ahead and simplify this completely. To do that, we're going to distribute 50 to negative 1 and n as we did in the previous example. And that gives us an equals 500 plus 50n minus 50. Alright, we can combine like terms here. The like terms are negative 50 and positive 500. If we combine those two, we're going to have an equals 500 minus 50 is 450, right? So we have 50n plus 450. So this is the formula that we can use to calculate the money that Jasmine spent on her phone after n months. Okay? So the last question is, how much does she spend in a year after 12 months? Let's go ahead and answer that question. I. Amount of money spent, amount of money spent in 1 year, right? That's what the original question asked. How much she spends after a year. So in 1 year, how many months are there? In 1 year, there are 12 months, right? So that automatically tells us that her n value is going to be 12. Okay, we already have the formula for calculating how much she spends after n months. Is an equals 50n plus 450. So all we're going to do here is just substitute and evaluate. Okay, so we're going to take 12, because that's what n is, and plug it in right here. Bam. Okay, n is 12, and we can also plug the 12, this 12 value, right, for the index, because that's what we're looking for. So A12 is given by 50 times 12 plus 450. Okay, let's use PEMDAS to evaluate this expression. 50 times 12 is 600 plus 450. And when you add these two, you have $1,050. Okay, so after 12 months, Jasmine spent $1,050 on her cell phone. Alright, so there goes the final answer. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of arithmetic sequences, do give us a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to the multiple numbers of math tutorials we upload to our page on a regular basis. If you have any questions or comments, just post it in the comment section below and we'll be more than glad to respond. More support resources can be found at mathgotserved.com under Algebra 1. Thanks again for watching and have a wonderful day. Goodbye.